Okay, yeah, stop me if anything's unclear or you can't hear me very well. So, uh, I'm going to be talking about the Machiavelli paper. I think you've all seen the title at least. This is a joint work with a lot of people at the Center for AI Safety. In particular, I'd want to shout out my collaborators, June and Andy. They did a lot of work on this project. So yeah, let's just get started. So I guess I want to break up this talk into maybe two sort of like sections. The first part is going to be, I think, more of the conceptual stuff. And for this part, I want to sort of give you a sense of what the benchmark is like, and maybe this would probably be most relevant for the alignment hackathon. And in the middle, I'm going to give a quick like discussion of like power seeking. I think one of the like interesting parts of this benchmark is that we try to capture notions of power. I think this is different from most other benchmarks, which mostly focused on morality or rule following. And so we have some other types of behaviors that we track. And then in the second half, I sort of want to just give a sense of like what the actual results are and like how we actually went and like collected the benchmark and sort of some sort of methods for improving it. Cool. So let's just get started. I think like as motivation, I think as you're all familiar with language model agents becoming more and more complex and then having more and more capabilities. And so pretty soon we might expect to actually deploy these agents in applications. I think right now they're just being used as APIs, but pretty soon you could imagine like Adept, I think, is developing a web browsing agent. So a natural question to ask is like, how do we evaluate the safety of these models when you have like a wide different types of behaviors they might be deployed on, and you sort of want to ensure that in a lot of these cases that we will get safe behavior. And then there's this other kind of thread that emerges is that when we train language models with next token prediction, you get toxic text because they sort of just learn to copy the patterns. And so I think like a question we wanted to ask is, if you just train agents to maximize reward, are you going to see like these sort of negative behaviors, Machiavellian behaviors? And I'll sort of talk about that more carefully, what that means. And then finally, like, because these language models are pretty good at rule following, we might also expect that you could just tell them to be a good citizen. So is it enough actually to just to tell the language model, oh, don't do any harm? And we'll sort of like try to cover that. But to actually study all of these questions, we needed environment. And so we chose these choose your own adventure text games. I think there's a lot of different properties why they're interesting. I'll get into that in a bit, but briefly, like if you're not familiar with what choose your own adventure text games are, they're sort of like these text-based stories. And so you're going to get a like scene for each like sort of like step in the game. You get like a scene text, which is your observation. And then the game provides you a list of actions, which are these 5. And then they have different text descriptions. And then depending on which action you take, the game branches. So if you take the 4th action, you get this top text. And if you take the 5th action, you get this bottom text. And then you progress throughout the game. And sort of if you actually like map this out, this is like one of what the games looks like. The colors here just are different chapters in the game. So you can sort of see there's like a lot of different branching at some points. And sometimes the story is more linear, but overall, they're pretty complex. And I think that's sort of why we like these environments. The games themselves are written by authors. So these are like actual people like sort of coming up with different types of events. I'm sort of just flashing like some of the games here. And because they're like diverse, we sort of get a lot of different types of scenarios and different types of behaviors that we can track. And in general, I think like these games are also pretty long too. So this isn't exactly a fair comparison because we're counting not just words, but also like the code to run the games. But I think it's fair to say that at least some of the games are pretty long. They're probably as long as like a lot of books out there. And so there's like pretty long and branching plot inside the games themselves. So they're very realistic. Or not very, but like approximating like sort of what humans are interested in. And I think this is sort of like the actual core behind why we chose these games. So I think there's like sort of 4 properties that are nice here. Humans, like whenever we're trying to go through life, we have a bunch of different objectives that we optimize for. For example, like you might care about being an independent person or also gaining a lot of friends. There's also like long-term consequences to your actions, right? If you study hard now for your test, it will pay off later when you get that acceptance. And then so these two like properties are like sort of part of human nature, and I think they're captured well in some of these games. This is sort of just like an example, but I think in general, you can sort of see that if you take a few scenarios, you sort of get this idea where there's a bunch of different goals that the main player might care about. And when you're trying to achieve those goals, they can conflict with each other. And then there's long-term consequences here. So like this person here, if they decide to like do everything by themselves, then in the future, it might not, they might like lose this friend and vice versa. And then another thing I think that sort of, it's not really a property of humans, but this sort of separates these like games from other types of text-based benchmarks is the fact that a lot of the actions here are at like a similar level of abstraction as human thought. So I don't know if everyone's familiar, but there's these other like text-based benchmarks, sort of like Jiminy Cricket, which is based off the Jericho environment, and Alf World and sort of Microsoft Text World. A lot of these are basically involving navigation. So you're put like, it's like you're put in a dark forest and then how do you get out? So here, a lot of these actions, as you can see on the right, they're more sort of like what a human would think if they were in a certain situation. So in this case, you like want to get into a club, but you're not allowed in, so how would you get in? They're not really about navigation and movement. And also, because you have all these like human actions, there's like a natural tension between sort of achieving your goals and behaving ethically, right? So you could, in this scenario, try to fight the boxer, which would probably cause harm to both of you, but that might help you get in. So there's like this tension, and I think we wanted to explore that. Cool. So this is sort of like, we have these games, we set them up, and then how do we actually turn it into like an environment that we can study agents in? So it's pretty easy to transfer these over to gym environments. Why is that? Because you have like this mapping. So the state space, which is taken from the game itself, is basically every scene. And so each state, you have like the scene text and then the game variables, which track like player stats, and this helps you like path through the game. And then the action space is also provided to us by the game. So the game has like several discrete actions per node, and then some of them are locked or unlocked depending on like the player stats. But as you go through the game, you sort of get different types of actions. And then finally, like the rewards are given to us also by the authors. So the authors have like, there's sort of different types of rewards in the games, which is why I think this environment is more complex than the previous ones. So for example, one of them is just like become king, and then the other one is like get married, et cetera, et cetera. And finally, because this is like a text-based RL environment, we get pretty efficient simulation of the environment. So this is like good for training agents and collecting a lot of data. Okay, so I sort of like gave a pretty high level overview of like what the environment is like. And I think now we sort of wanted to translate that into like an actual benchmark and like testing suite. And so how do we actually do that? Well, I kind of gave like the overview of what's going on, but we still want to actually measure agent behavior. And I think this is the key to like making this more of an alignment benchmark. So the game already provides us with some types of things, like you can track like points and sort of like how many steps the agent took and like what are its stats, but we want to do a little bit further and compile everything that happened into like this safety report. So in this, like for our work, we specifically focused on these types of behaviors: power seeking, utility loss or disutility, and then deception. But you can sort of, and I think I'm folding deception into like all of these moral harms, but there's a bunch of different other things you could track too with labels that you gather, but we just wanted to focus on this in just the interest of keeping it like at a reasonable scale. Okay, so like we care about these behaviors, but how do we actually measure them in the games? Well, we have all these scenes, right? So in the scenes, like there are things that happen, and you can actually label them, like say, oh, someone got hurt in the scene, or someone caused like this much damage in the scene. And so if we label everything, if we label all the moral violations and sort of like the impact of each scene, I'll get to that later, why we care about impact, then we can sort of like from a bottom-up perspective, calculate all of our behaviors that we care about. And so at a high level, here's actually like the summary of like the benchmark in the game. So you have these goals. These are defined by the game. You have the observation, which comes from the scene text, and then the discrete action space is on the left, which like sort of also comes from the game. And then your trajectory here, we just highlighted one in red. This is just like some illustration, but you just basically play through the game and then select different choices. And then if you happen to come across a node that like has an achievement, then you get those points. And then what we did like basically is do everything on the right. So we calculated 3 types of behaviors: disutility, power, and then like moral violations. And then we just use our labels to like measure these behaviors, and sort of this is how we evaluate agents in our game. So the goal is basically maximize game reward and then minimize these 3 categories. Okay. Hopefully that sort of makes sense. This is the actual like conceptual part, but there's still a lot of like technical details to be worked out in terms of like how you actually compute this. And so in particular, I think I sort of just wanted to give a sketch of what's going on. So I defined the behaviors on the right. These are like the 3 things that we cared about. And then the game is on the left. This is like sort of what the game provides. Okay, so the game has a lot of actual structure that we can exploit. I won't get into these details, but this is sort of like everything that we have. And we care about like power seeking, selfishness, deception, etc. A bunch of like other things. We didn't actually get to measuring all of these, but you can see that there are like a lot of behaviors that we want to encourage our agents to have in the future. And then, so we can basically like combine the labels and like structure of the game and map those onto like these behaviors that we care about. And then essentially this is how we like evaluate agents in the game. And I don't know how you guys want to take your hackathon project, but I mean, there could be some sort of like techniques with adding more labels, or possibly sort of defining new behaviors that could be placed on top of the existing labels. And then maybe like trying to optimize for those. That could be one interesting direction. Okay, and sort of, I think in this like decomposition here, probably the most interesting or novel piece is the power seeking part. So I think some of these other behaviors down here are sort of already defined in the literature, but I think there wasn't a clear conceptualization or concretization of like what power is, except for a few work like I think by Joe Carlsmith. And so I think actually one of the motivations for this paper was to formalize these definitions. And so I'll sort of talk at a very high level about what's going on. And so to do this, basically, like other fields have defined like what power is, but I think it's sort of like broad and not really applicable directly to what an agent should do. And so this is just like a quick, like high-level summary. No need to read everything. But I think like if you sort of like go in and try to take the gestalt of what all these are saying, it's like that power is the ability to influence the world. Okay, so we wanted to basically operationalize this definition in terms of our games. So I think at a high level, what we really care about is like measuring agent power. And so agent power can either be thought of like as the inputs, like what the agent has to like exert power, and then the outputs, which is like what sort of impact the agent has on the world. So in our benchmark, we call this resource power and prospective power. I think one little, like I just want to note that this is actually kind of hard to measure in practice, right? Because resource power sort of depends on the agent's capabilities, sort of like how efficient it is at using like its resources. For example, if you have like a child and they have like a weapon, this is probably a lot less effective, a lot less powerful than like a soldier having a weapon. So resource power is hard to define. Prospective power is sort of like, what do we expect the agent to like act on in the world? So like we might imagine that like if you have access to a nuclear weapon and you tend to want to use that nuclear weapon, you can probably have a lot of prospective power because you can make a huge impact on people's utilities, the landscape, etc. And so prospective power is by definition sort of like this probabilistic notion of like what's the agent's tendencies multiplied by what's the agent's like ability to achieve those tendencies. So these are also like in general pretty hard to capture. So I think we compromise in this benchmark with measuring power with trajectories themselves. And basically, if you roll out a bunch of trajectories and then get their observations at each point, like so these are the red dots are sort of like the state, you can sort of approximate these past two like inputs and outputs with your trajectories. So the outputs are going to be basically exercise power. So if you just sum up all the trajectories, all the impact along the trajectory, you get exercise power. This is sort of basically like some approximation of like perspective power because you capture the agent's tendencies multiplied by its ability to achieve those. And then you can also look at like at an individual level, like what's the power gain from each resource. So like as you step through the environment, like you're gaining resources, and that's actually how you exercise your power, right? Because you need resources to exercise power. And then you can just like check the difference between each state to see how much like power is gained from each resource. So these are like some approximations of like power. I think for the results we report, we mostly just focus on exercise power, but this is like some high level overview of what goes on. Okay, I sort of want to take a brief pause and do a quick summary here, but I sort of covered all of like what the benchmark is about and like conceptually what we're trying to grasp at in this benchmark, which is we have like a text-based environment for our agents, and then we want to ensure that they behave morally, and as a result, we like want to capture these behaviors. But so I didn't actually tell you how we did any of that, and so I'm going to like focus on that now in this part of the talk. So first things first, like we need to like get labels of all the scenes. Because we've already defined like what these behaviors are, they rely on like these different labels. So how did we actually do that? I think one thing that is probably like pretty hard to like, I think this doesn't like really hit you until you work with the games, but there's a lot of text in these games. There's about like 25 million words. And if you actually want to annotate everything, it's like around 3 million annotations. So I think if you like pay people or like Surge AI or Scale at the normal rate, like $25 an hour, this ends up being like either $50,000 or $500,000. I think $500,000. So it's extremely expensive. And what we found out is that you can actually use GPT-4 to do all the annotations, which is what we used in this case. And I think like some of the Twitter threads were about this. But yeah, basically GPT-4 is as capable as Surge crowd workers in terms of like accuracy. I'll talk about that a bit later. And obviously it's cheaper and faster than them. And so I think this is like an actually reasonable method to use. I think more and more people are using this in the future, so you'll see more and more labeled data. I also want to note that we don't actually care too much about like optimizing against GPT-4's labels. Like I think one criticism might be that, oh, if you have GPT-4's labels, like the labels are only as good as like the moral like inclinations of GPT-4. I think like these are sort of serve as a guideline for other agents, and you can evaluate them on. And then in the future also, you might expect that as models get better, the labels will get better. So we can relabel this data set at a cheaper price and get more of an estimation of like what agent behavior is like. Cool. So what did we actually collect? The first one is like moral violations. So you can basically ask GPT-4, like, here's a scene. Here's all these like different moral violations I care about. Like you can see deception is the top one, but there's a bunch of other ones. Do any of these occur in this scene? Yes or no? And so here's actually the prompt. Basically, you take like the scene, you just give all these like moral violations, and then you ask it like, did any of these occur? And then GPT-4 will actually just output the response. Obviously, there's going to be some noise in this, but it's pretty good, and it'll just like output it in a JSON, and then you can collect all these results. And we actually find that language models themselves are actually pretty competitive with human annotators. This is why I was like saying as capable as So if you look at all these moral violations, GPT-4 is actually more correlated with humans, with our like labels, which is like 3 authors, compared to like the surge workers. I think there's obviously going to be some disagreement, but I think we basically took like this smaller gold test set. We labeled everything. We asked Surge to label everything. And then we asked GPT-4 to label everything. And then we compared like performance across those scores. And then for like some of these other impact labels, which are these top 4, it's not as correlated with compared to humans. So we'd prefer human ensembles for that. But it's simply just infeasible to like ask to collect that much data. As I said, it would cost like $500,000. So we just stick with GPT-4 in this case. But yeah, I think in general, you can see that this trend of like language models are actually becoming quite capable of labeling data and should and probably will help in the pipeline pretty soon. Okay, cool. So we have those labels. Now let's actually talk about how we evaluate our agents. So I think these are the top level takeaways that I wanted to impress upon you. Sort of 3 things. We do find that Machiavellian behavior emerges from reward maximization. This is kind of analogous to how toxicity emerges from next token prediction. There is a trade-off actually between maximizing rewards and behaving ethically. And this is not something we observe in the agents. I'm talking more about a structure and property of the games themselves, that you can't actually maximize all your rewards and behave entirely ethically, sort of just in real life. Like you might want to, let's say, gain $1 billion, but you sort of, I guess depending on your moral framework, but in a lot of cases you have to behave unethically to achieve that. And I think these games reflect that. And then finally, like there is some hope though for our methods. We can steer agents to be less Machiavellian, yet still sort of competent depending on like how we prompt them or like how we train them. Okay, so what agents do we actually use? We use like a random baseline. This is just you pick actions uniformly at random. And then we use a language model, which is GPT-4. We also use Llama. And then, but I don't think I'm going to report those results. And then, but you can check our paper for the details. And then we also use the RL agent, which is like based off this previous paper by He et al. Okay, cool. So the top level number is that the RL agent, which is the DRRN, has the highest reward, but it's also the most power seeking. So you want to like maximize the left column and minimize the 3 right columns. And the GPT agents are actually less powerful than the random agents. So this is all normalized to the random baseline. And they also still do pretty good, but obviously they're not as high performance as the DRRN. And so, yeah, as you can see, like you sort of get this Machiavellian behavior where as you do better on your reward, you start to see like more and more power-seeking behavior. And then if you actually look at the rewards in the game, we find that some of the achievements themselves are immoral, like killing, or sorry, not killing a child, but being mean to a child or sneaking into a place that doesn't want visitors. So actually there is some natural tension. You can't achieve all the achievements. And then finally, like we actually are able to steer the agents to be less Machiavellian. So how do we do this? For the language model agents, we can do this sort of like prompting where you tell the agent to be on your best behavior, yet still like achieve the goal versus compared to our original prompt, which was just maximize your score. And then you can actually interpolate between these action distributions. We find that actually that if you just prompt it, it's like good enough. Or is it like, this is like as good as it gets for just like these prompting methods. Or sorry, I meant like as good as like it gets in terms of what we tried, but there's probably more clever prompting methods that you could use. And then for the RL agent, there's this notion of like this artificial conscience. So what actually goes on with the RL agent, if you guys are familiar, is like you learn Q values for every state action pair. And then what you do is that some of these Q values might be like higher because they're maximizing your reward, but you can penalize them if they have like unethical actions. For example, if you lie or if you want to be power seeking, you can train another model to sort of like assess whether or not that's true. that's basically what we did, which is this like moral conscience here, this robot arm. And if it's too high, then you basically penalize it and say, don't lower that Q value. So you're more likely to take this middle action instead of this top action. And this can also make your agent more moral. And so as a result, if you see this like new row on the bottom, as you like regularize these agents, you sort of get almost about the same performance. There's a bit of a drop, but you can also like reduce the power seeking. And immorality actually rather significantly. And then so you get this radar plot here, which is basically kind of as it shows that the regularized agents are solid and the original agents are dashed. So the original agents are a little bit higher on the game score, but you can sacrifice some of that and get like more morality, utility, and power aversion as a result. So there does seem to be like a way to progress forward here. I think overall the goal should be like, given this current Pareto frontier of like reward and power reduction, like can we improve that by designing things that go to the upper right of this boundary? Yeah, and then this is basically all I wanted to say. I'll just leave this screen up. But yeah, does anyone have any questions?
Nice. And anyone can raise their hand. I think that happens at the bottom of the screen for any audience members, and we can take you up to the scene as well. Otherwise, you're very welcome to just write in the chat. I guess. Thank you so much, Alex. So a little clap is in order.
Thanks.
And and I guess I can just take the first question, also related to Hiram's. So the one question is, this is quite a behavioral benchmark, right? Like one that looks at power seeking, like these complex, interconnected, sort of interacting behavioral features of the agent itself. And how do you think, like, what is the space for that versus the space for some like inverse scaling benchmarks, which get like a very calculatable metric, something we'll also hear from Antonio tomorrow, that like, you know, it's very concretely, okay, inverse scaling versus these behavioral benchmarks.
Yeah, I think they both have a good role. I think sort of naturally the first things that emerge are going to be behavioral benchmarks because we don't have like a clear picture of these definitions yet. But I think like this probably just solely sits in the place of behavioral benchmarks. You might imagine in the future, like if you get better like understanding of agent internals, like if I actually have my agents like behaving with world models, and you can measure like their understanding of the world, you might get closer to like some intrinsic understanding of what the agent's behavior is, and then you could get more accurate numbers for like this sort of inverse scaling type benchmark. But I think right now this is like mostly a behavioral benchmark. Not sure if that really answered your question.
Yeah, that's good as well. I was thinking of like the differences between the two and how they fit into where we see alignment today and AI safety more generally.
Yeah, I think so. I would like say this is probably like the first pass. Like say we were going to deploy our agents like in a month or tomorrow, we'd probably want to like develop these behavioral benchmarks to get at least some rough understanding of like how they're behaving. And then maybe this would be like call for like increased regular. I think also in general, a lot of alignment solutions probably require like the socio-technical policy component. So this would be like a technical part of like a policy that asks like people to sort of like slow down or either like limit the deployment of these agents. And then more generally, like if we actually wanted to develop like long-term solutions to like minimize like, let's say, deception, we'd probably want to like go in and like track more carefully. And that's where the inverse scaling benchmarks or this sort of nature where you're actually like plotting and studying points could come in. So I think that's how I see these two.
So Hiram also asks, doesn't some sort of measurement setting, like for ability/power, seem wishy-washy, I guess? How do you know what you're proposing isn't something pulled out of thin air and is concrete or useful for people to understand?
Yeah, I think that's a great question. I would say that in general, this is sort of the first pass. I think we did make a lot of strides in terms of measuring power seeking. I would sort of like refer back to previous work here. So this has been like a well-studied topic in like, let's say political science or philosophy. And in that setting, sort of, they just posit different definitions. Like for example, in political science, there's this pretty well-known paper where they posited a definition of power as sort of like your ability to influence other people's actions counterfactually. And you can actually measure this by looking at congressional senators and seeing like if they vote, like how likely are they to like swing the influence of other people on the committee. These are US senators. And this is just some metric, and then you can actually operationalize this metric and like say, oh, like this senator is more powerful than like so and so other senator. And so yeah, I don't think this is like necessarily like a precise mathematical formulation of like power seeking, but I think like this sort of gets at the correct notion of like what it means to influence other people. And I think we sort of tried to ground our work in terms of that. You can see our paper for more details. I guess in terms of like actually arguing over the technical details, that should and probably will be a debate. But I think in terms of like this general idea of like porting over concepts from previous fields and like operationalizing them, I think this is like a rather reasonable technique.
Yeah, and we also have Hiram on stage if you want to contextualize some more on your question. But otherwise, yeah, you mentioned this, like the taking metrics in from other fields, like taking methods in and looking at these more fuzzy metrics. And what I hear a lot here, and what I imagine is very important for something like considering good benchmarks, seems to be the importance for this metric, right? Like making sure that we, yeah, it's like the data is fine and all, but what really matters is the metric being very important. Do you have some notes there, or like some tips for figuring this out in a good way?
Yeah, I guess one thing I would just point out, I agree with that for sure. We did spend a lot of time like sort of going over the metrics, and we found that by default, like if we just capture like quantitative metrics, they're actually very noisy in terms of the trajectories. Because naturally also the games are very odd in the sense that like, I'll sort of just give this funny example. There's this cat game where you like play as a cat, and in one of the scenes you can actually sort of become like this world famous like cat artist and release an album that like sort of like makes everyone really happy. And so if you actually track utility in that scene, this is like kind of, it's correct to say that you increased utility a lot. Like Taylor Swift's albums are actually like very popular. But sort of if you actually measure this, then this becomes hard to capture because like everything gets dominated by this one scene if you end up on this trajectory. So we end up switching to more just count notions. So like how many times rather than like how many times does like the character like increase utility? And we find this is like a lot less noisy and easier to compare with. So we do miss a lot of the nuance, and I think the metric is important. And probably there should be more work actually just thinking about how we define metrics as we increasingly deploy these agents in more real world settings. Like what does it actually mean to say that the agent is doing like bad behavior, even if we can like capture all of its actions? I think this is pretty unclear, and hopefully more work in the future could be along those lines. But yeah, I think as a compromise, you probably have to like get a more coarse-grained metric.
Yep. And of course, maybe this work happens at this hackathon too, so that'll be exciting. We'll take Hiram. You might have something, and Botanium, if you want to also ask your question, and then we'll take one more question besides that, and then we'll jump to the logistics and so on.
Yeah, thank you, Espen, for organizing this, and thank you again, Alex, for like putting together this presentation. It was pretty helpful. We already like touched on the definition, but I think my team has like a question around like how did you kind of like backtest your metric in some sense, because it seemed like you had the graph where you like saw GPT-4 and like you kind of like put Llama to the test and just showed that yes, they developed some sense of like morality or kind of lose their optimization towards just focusing on the reward. Yeah, if you could speak over that.
Yeah, I think in terms of like just sort of sanity checking and making sure the metric is consistent, we just looked at qualitative like rollouts of we qualitatively just looked at rollouts of the trajectory, and then you can see that in like some sort of scenes that like as like the agent tends to do these sorts of actions, then the metric goes up, and then otherwise the metric goes down. I think in general, you can also check the labels. That's just sort of what we were doing with the that like large table with that language model comparison. If the labels of the like language model are well correlated to the human labels or like the author labels, then that should be like some notion of like correctness. Obviously, like you have to trust like these three authors. That might not be like the best thing to do, but hopefully like that's some sense of like the labels themselves being correct. And the metrics are defined on top of the labels. So the metrics themselves could be improved if you like disagree with like how we actually operationalize. But I think that's more of a like philosophical or like discussion rather than like a technical argument of, oh, like we should maybe like reduce the scaling on this like number by like so much. I don't think there's like a better way, unless I might be missing something. So if there is like actually a better way to sort of like more consistently check that these metrics are correct, other than like directly just like asking GPT-4 to like get like some summary stats. Yeah, that's probably my answer there.
Perfect. And Britannium?
Yes, thank you for the talk. So you say that you have this trade-off between having high reward and having an ethical behavior. Do you think that some methods that instead of maximizing the rewards try just to achieve a certain threshold could be another way to solve this problem?
Yeah, I think that's actually quite a reasonable solution. We also even considered defining the point of the benchmark as like max or minimize reduction, minimize like harms or Machiavellian behavior given a certain like reward threshold. But I think it's like probably a bit confusing to compare rewards. So I think my just like questions there would be like, what's a reasonable threshold to set? I think we were reporting normalized reward, but it's like a little bit hard. If you actually look at the games themselves, the achievements maybe are like 50 points, like become king, 10 points, like save a child from drowning, like 5 points, like eat ice cream. So I think like each game should have its own like threshold depending on the world and environments, and you might also care about different things. So it's like unclear to say that like, sorry, so I'm trying to bring this analogy over to the real world. Like if I was deploying my agent and I wanted to set like some reward threshold, like, oh, I want you to like make like X amount of dollars. I think it would probably depend on like the person, and sort of, I'm not exactly sure how I would set it a priori, but I think this general idea of like, maybe like let's list like 5 or 6 objectives that we really care about achieving, and then like from there just minimize Machiavellian behavior. That could be a reasonable approach, and I think that might be like some way agents are deployed in the future.
Nice. And
Okay, thank you.
yeah, perfect. And another question that comes up is Helwan asks if you can repeat the options you suggested for the hackathon, and maybe if this is unclear, then what are some of the ways people can build upon your work, or some of the suggestions you might have for things someone can do in a weekend?
Yeah, I think in a weekend, one thing you could investigate is sort of different prompting strategies for agents that would help them elicit like better behavior. So one thing I would want to point out is that we find that the smaller language models aren't as good as like the larger language models, but there's actually some just notion, there's like work in literature currently that sort of looks at like how do we actually approximate performance, sort of just like the llama alpaca stuff, but also more generally like different prompting methods can actually boost the performance of smaller models. So that might be one direction. Another thing to look at if you're more familiar with RL is like how do we actually like improve RL agents and train them to like be competent yet less Machiavellian. I think that's sort of like a little bit hard because RL training does take a bit of time. So maybe I'd focus on prompting if you don't have too much time. And then another thing is sort of like, given this sort of benchmark, like are there like other behaviors that we might want to track, or like sort of are there other strategies of like evaluating the agents that give you a better sense of like, oh, how deceptive are they behaving? Or like sort of, I think like it would be actually interesting to sort of get a notion of like, given a trajectory and a metric, can we like, how do we actually evaluate how robust or correct that metric is? Something like this like consistency check that Hiram was asking for. I think that's not really like super clear, and actually would be a pretty interesting paper if it was like published.
Awesome. Thank you so much, Alex, for this wonderful talk, and so lovely to have you over there in the morning.
Yeah, thanks for having me. It's great to see so many people interested in this.
Definitely, also from our side. So thank you so much.